Okay, we're going to do one more of these cost per unit questions. This is 51. Ketchup is the object, is always dollars per unit. So we'll just write them all down and then do the calculations. Now, usually in the store, they'll actually write what the per unit pricing is, which is what I always look at when I'm shopping. Now, let's see if we can just look at these and decide which one looks the smallest, just by estimating. So this is going to be, this is about 0.1 ratio, because this is close to 1.4. This is 14, so there's a factor of 10 difference. So this is about 0.1. This is going to be, to get 0.1, I'd have to have $2.40, but it's less. So this is cheaper than that one. This one's going to be about 0.5. This is a little bit more than 0.5. This were 12, like $1.20 something. So this is smaller. And then this one is actually around so this one's about 0.5. These are very close. I think this one's actually the cheapest one, just by estimating it. Anyway, let's plug the numbers in and see what we get. 1.39 divided by 14 is 0.099 dollars per ounce. 2.55 divided by 24 is 0.065 dollars per ounce. 1.78 divided by 36 is 0.049 dollars per ounce. And 3.99 divided by 64 is $0.062 per ounce. So now we'll compare these and look for the smallest. Well, this is the smallest, and so this is the Best Buy. Best Buy is always the lowest per unit cost per unit of whatever it is. Okay, 54. So 54 is a triangle situation. And this is chapter 7, geometry is chapter 9, but it says that any two times, if you read the book, it says that we know that if two triangles are similar, we can set up a proportion to solve the length of any unknown sides. Use the proportions to find the lengths x and y, given that the pair of triangles are similar. So similar triangles have the same angles, they're just larger or smaller. So what we have is, what we can say is that 3 to 12, which is the left diagonal side, if we look at the ratio between the right diagonal side, the same numbers, and then the ratio between what we do is the smaller triangle and the larger triangle. So the numerator is the smaller triangle, the denominator is the larger triangle. So we already know that's true. So we just have to use one of these. We don't have to factor both of those in. So we have this proportion, which we can then cross multiply. 3 times x is 3x, 2 times 12 is 24. Divide both sides by 3. 3 divided by 3 is 1. 24 divided by 3 is 8. So the unknown side length on the second similar triangle is x equals 8. Okay, we go to 57. What's that? May not be a triangle. Okay. So for the problems 57 and 58, draw a sketch consisting of 2 right triangles depicting the situation described and solve the word problem. So it says, an enlarged version of the chair used by George Washington at the Constitutional Convention casts its shadow 18 feet long at the same time as a vertical pole 12 feet high casts a shadow 4 feet long. How tall is the chair? So basically we have chair length to shadow. And the reason that the proportion is the same is because the angle. So if you have a sun and you have two objects that are in the same location, basically, that each one of these is going to create a shadow, and well, yeah, the sun. It's hard to draw that way because the sun is a very large distance away. So that actually demonstration wouldn't do it. But anyway, in the case of the sun, which is very far away, the angles, they're going to be basically similar triangles. You're going to have this side is going to be the height of the thing, and this is going to be the shadow. And for the smaller case, you still have the same angle here between the sun and the ground. So all we have to do is just set up a ratio here. So you just have to make sure the shadows are in the same location or in the same proportion. So let's say we have 18 feet is to something as something is to something. So 18 feet is the shadow. So let's put the shadow down here. So it says the cast shadow 18 foot long at the same time a vertical pole 12 feet. So let's do shadow to shadow 4 feet. So this is chair to shadow. We need chair to shadow. Actually, what we're doing here is we're doing shadow to shadow. We do need, this is chair to pole, chair to pole. So it says, so the pole is 12 feet, and we're trying to figure out what the height of the chair is. So since the chair casts a longer shadow than the, make sure I'm doing this right here. Yeah, I think I wrote this and then I did something differently. I mean, I could still do it this way, but I don't want to disagree with what I had earlier. So, well, maybe it is. So this is, it really should be object length to shadow length. That's where I made my mistake. So the object, we're going to put that in the numerator. So let's try it again. So this is going to be the chair, this side is going to be the chair, this side is going to be the pole. So the object length for the chair, that's what we're trying to figure out. So that's X. The shadow length for the chair is 18 feet. The object length for the pole is 12 feet. The shadow length for the chair is 4 feet. So what I've done is chair length to shadow of chair length, pole length to shadow of pole length. So now we just have to multiply it out. You get 4x is equal to 12 times 18. 12 times 18 is 216. So x is 216 divided by 4, divided both sides by 4. And I get 54 feet. So the chair is 54 feet tall. And yeah, okay. How many problems did I do there? 51, 54, 57. Okay, that's a good place to stop.